Right. Hello, everyone. Thank you for joining us online tonight. My name is Katie Miles, and I am the Public Services Librarian at W.J. Niederkorn Library. We are grateful for this opportunity to host UW graduate student Linnea Rock for a virtual Badger Talk titled Wisconsin's Freshwater is Getting Salty. And before we get started, I'd like to remind everyone to keep your audio and video on mute throughout the presentation. After Linnea is done speaking, we will open the conversation to questions, and you can type your question in the chat at any time, and then we'll come back to those at the end of the presentation, or we might have a chance to squeeze it in during the presentation as well. All right, I would now like to give a warm welcome to Linnea Rock. Linnea moved to Wisconsin from New Hampshire to attend UW in 2011. Between undergraduate and graduate school, she worked in environmental advocacy, education, and the Department of Natural Resources Water Quality Bureau. She is now a second-year master's student at the UW Center for Limnology under the advisement of Dr. Hilary Dugan. Linnea's research is on chloride in the Upper Yahara River Watershed. Thanks so much for joining us tonight, Linnea.
Thank you. All right, I'll go ahead and get my slides up. Okay, yeah, thank you so much for having me here and for participating in this talk tonight. I'm really excited to share what I know with you. So again, my name is Linnea Rock. I am a master's student at the UW Center for Limnology. And I really like learning about how things that we do impact freshwater ecosystems and freshwater as a resource. So salt is a perfect thing for me to study because, you know, we throw it down on the roads and we use it for public safety, and it causes some problems in our water. So these are a few of the ways that humans negatively impact freshwater. And salt isn't listed on here, but it should be. But salt also is impacted by some of these things and interacts with some of these things. And in all cases, water quality is worsened. So an example of an interaction would be excess salt in a lake and excess phosphorus can combined lead to larger and more frequent harmful algal blooms. And another example is, of course, increased urbanization. There's more roads, more people, we require more salt use, and therefore more salt gets into our water. Okay, so don't worry about trying to read everything on this slide. It's a little chaotic. Just because of what I study pretty much every single day, I am doing some sort of search for a scientific article about chloride or about salt in the environment. So this was a little experiment where I wanted to see what kind of information I could find by just doing a regular Google search. And there's no lack of information out there. So these are headlines from sources like National Geographic, the Washington Post, NPR, as well as a lot of local newspapers in places like Ontario and New England, and of course the Midwest. So this is a widespread problem. And there's a lot of public interest, enough to get these, you know, big headline stories out by newspapers like the Washington Post even. So that is one of the reasons why I really like studying it, is the public interest. It gives a lot of opportunity to have talks like this and engage with people and help spread awareness for why this is a problem and what we can do better to prevent it from getting worse. So people have a relationship with salt. You know, not only do we eat it and it makes our food delicious and it's great on a, you know, chocolate caramel, but we also use it on our driveways and we use it in our water softeners. And we see it being applied, by massive trucks on our streets and our sidewalks. And one of the most encouraging things for me is that most people really care and they want to know how to prevent their salt use from causing harm. So this is a graph that shows salt use in Minnesota. And we use this because we believe that the sources are the same and that the trends are very, very similar here in Wisconsin. So the bars on this graph represent how much chloride enters the environment from the salt sources, which are on the x-axis here. Sodium chloride, or rock salt, same thing as table salt. I guarantee most of you have it in your kitchen right now. This is the most commonly used salt for water softeners for road de-icing. And once chloride is in the environment, it's not really used by anything and it doesn't react with anything. So when the sodium chloride dissolves in water, those ions separate and chloride just kind of stays dissolved in the water and doesn't leave. And that's part of why chloride is becoming an issue in our fresh waters and why they're becoming salty. So you can see from this graph that road salt is by far the largest source of chloride. It's more than double anything else. But some other important sources to consider are agriculture and water softener use. On average in Wisconsin, we spend over $80 million on road maintenance, and half of that cost is the salt alone. And in 2019, the 2019-2020 winter, in Wisconsin, we used 426,000 tons of road salt on our roads in the entire state. So this is a tweet from SaltWise. I'm just going to put in a quick plug for SaltWise. They are a coalition of organizations that promote healthy salt use. And if you haven't heard of Wisconsin SaltWise, I highly encourage you to check out their website. They are committed to just getting free information out there that's easy to digest for anybody. It's a really, really great resource to learn about your own salt use, about salt use on parking lots, about your water softener. I highly recommend you check that out. But this sort of reiterates that point where salt doesn't go away when we put it down. You might not see it the next day, but it hasn't gone away. It has dissolved and it's moved on to its next phase in the environment. And a little surprising fun fact is that road de-icing is the #1 use for salt in the United States. And in 2019, in the entire US, we put 42 million tons of road salt on our roads. So think about 42 million tons is now going to be in our water. Okay, so here are a couple of examples of where our salt might go after we put it down. So in the photograph on the right, when I took this, there was a parking lot right behind me, and just beyond the frame of the photo, there's a steep embankment to a stream. So of course, this salt was on the parking lot, but now it's just sitting on the grass, not helping anything, about safety in that parking lot. And these chunks of salt were about the size of my foot. So they're quite massive for a chunk of salt. And that stream that's just beyond the frame of this photo can sometimes have concentrations of chloride over 1,000 milligrams per liter. On the left, we see a red truck dumping snow onto a big dirty pile of snow. So this is like when a bunch of snow is plowed off of a road or a parking lot and it's stacked up, and then they come pick it up, throw in the truck, and they drive it away somewhere. Again, it's not disappearing magically. They have to store it somewhere. So this is on the UW campus, and this is all the snow from parking lots around campus. And of course, that snow is full of road salt. And directly next to that truck right here is a marsh, and that marsh can see chloride concentrations over 10,000 milligrams per liter, which is about half of what the ocean's concentration of chloride is. So a pretty significant increase from what it should be. All right, so a little bit of information about numbers that matter when it comes to chloride concentration. So in order for something to be a chronic problem, it needs to be a persisting, reoccurring problem. So lakes and rivers that have chloride concentrations above these 230, 395 milligrams per liter are considered chronically impaired. And in order for something to be an acute problem, it just needs to occur a couple of standalone times. So the EPA recommends these thresholds on this slide. And they say that levels above these concentrations are detrimental to aquatic ecosystems. And the DNR guidelines are based on some tests and some reviews that were done by the Wisconsin DNR. And we use these to determine if a water body is impaired for chloride in the state of Wisconsin. So it's important to note that these guidelines are derived from a broad range of laboratory tests, and they are not tested in the natural environment. So there are some really sensitive species that are negatively impacted well below 230 milligrams per liter of chloride. And I'll have an example of this later on in the slides. But there's also some tolerant species that can handle concentrations much higher. So we still have a lot to learn about how aquatic life responds to our salt inputs. And these are just guidelines, and they shouldn't be taken as like a perfect standard. And the taste threshold here is the concentration of chloride when most people think that their water is starting to taste salty. And if you're wondering how much salt it takes to impair a body of water, if you have a 5-gallon bucket of fresh water and add just 1 teaspoon of salt, of regular, table salt, that will permanently impair that water to 230 milligrams per liter, that EPA threshold. Okay, so some of the risks of salt and what it does. Species are adapted to the environments that they live in. So you can't take a shark and expect it to survive in Lake Michigan, just like you can't take a walleye and throw it in the ocean and hope that it's going to be okay. And I like to kind of use this analogy. If you're stranded in the middle of the ocean and you are just so dehydrated, you cannot drink the ocean water. It will dehydrate you further. So our bodies like to be at homeostasis. And if you start inputting a ton of that salt water, the little bit of water that you have left over in your body's cells will release, and you will just become more and more dehydrated. This is the same thing that happens to organisms that are adapted to freshwater environments. Invasive species could potentially increase with increasing salinization of freshwater. Invasive species tend to be better at adapting to new situations. So this is still something that we are learning about. And salt also has some consequences for the physical nature of lakes as well. Okay, so this picture on the right is of a zooplankton called a daphnia. And these are really important parts of aquatic food webs. They eat algae, so they keep our freshwater, clear and clean. And they also are a really important food source for some things higher in the food web, like, some fish that we enjoy catching and eating. So the graph on the left shows the ability of Daphnia to reproduce with increasing amounts of chloride. This was an experiment done using some Daphnia from lakes that are soft. So in Wisconsin, we have hard water. It has an excess, or not an excess, but it has a lot of minerals. Not all water is like that. Some water is very soft. And these zooplankton, these Daphnia, you can see like well below that 230 milligram per liter threshold recommended by the EPA, they were unable to reproduce. And so reducing the abundance of critters like these can have a very serious impact on ecosystem services. And it can also include things like, our drinking water, fisheries, and recreation that our lakes provide. Okay, so most lakes in Wisconsin are called dimictic, which means that they mix twice a year. This is really important for nutrient and oxygen circulation throughout the lakes. Salty water is much denser than fresh water. So if enough of it accumulates and sinks to the bottom of the lake, that layer can become too dense to mix with other layers and essentially create what we call a dead zone in the bottom of the lake. And that will only get worse as the lake is unable to mix and that dead zone increases in size. So I have a news clipping here on the left side of the screen. This is an example of a lake in New York in a state park, a protected natural area that has stopped mixing completely because of road salt use. We don't have any of these lakes, or we don't know of any lakes in Wisconsin that have stopped mixing yet. But there are some in Michigan, and I believe there might be a couple in Minnesota as well. So not only is salt bad for our aquatic ecosystems, but for our vegetation that is also adapted to a fresh environment. So you might have seen trees like this. They look like they're burnt or like they're rusted on the side of the road, or shrubs on the side of a sidewalk. That is directly from road salt. And some of our most susceptible species here in Wisconsin are sugar maples, spruces, and red and white pines. So road salt is very, very corrosive and can cause some trouble for roadside infrastructure and for drinking water infrastructure. So, we put it on our roads for public safety, but when we have too much, it is very corrosive, and it accelerates the rusting that can happen on our, steel structures that we also need for public safety. Salt doesn't all immediately rush to surface water, to a lake or a stream. Some of it can, sit on the side of the road and infiltrate into the soil. So not only does that destroy soil structure and increase problems with erosion, and of course, we don't want our roadsides to be eroded because that is a public safety concern. But it also is stored underground in the water, in the groundwater, and will slowly leach out to surface water. And how long that takes is unknown, or it depends on the flow path of that specific part of the groundwater. And some groundwater is intercepted by a well before it can reach a body of surface water and be flushed out. And so if that happens, that is going to be salty water that's taken up through that well. And this really leaves a pretty big unknown question about how much chloride we have stored in the landscape in Wisconsin and across the United States. So 75% of people in Wisconsin rely on groundwater as their drinking water source. So having salty water in our groundwater can be a very, very serious problem. And even if we stopped salting today completely, it's unknown how long it would take all of that salt stored in the groundwater to flush out of the system. All right, so here I'm going to start getting into some examples of where it's occurring around Wisconsin. So this is a graph of chloride measurements in Minnesota and Wisconsin lakes and streams. With the lighter colored dots means there's more chloride present in that water body. So you can see that especially around the more urban hubs of these states, there are concentrations, that are super high. That's where the biggest problems are, and that is from road salt. But there also are some concerning lakes, even in these northern areas, that are in the 10 to 1,000 milligram per liter range. So this is a widespread problem in our state. It's not only in those big cities like Milwaukee and Madison. It's happening everywhere. So this is a graph of chloride concentrations in the Yahara lakes in Dane County. And two of these lakes I study, Lake Mendota and Lake Monona, are a part of my research area. And so we were lucky enough to have data back to the early 1900s in these lakes, not on this graph, of course, but we know that before we started applying road salt in the 40s and 50s, these lakes were in the 0 to 10 milligram per liter chloride concentration range. So essentially, over time, we have added enough salt to this environment that these lakes are 50 to 100 times their natural concentration of chloride. And a lot of these super high spikes that we see occur during the winter and at the bottom part of that lake. So even though these lakes aren't at that dangerous level, the 230 milligram per liter level, they are approaching that. And in the winter, sometimes they do reach that level at the bottom of the lake. Okay, so these are 3 rivers in Milwaukee. And the gray dotted lines are those EPA thresholds of 230 and 860 milligrams per liter. So during the summer months, they are okay, maybe reaching that 230 milligram per liter mark, but in general, they seem to be fine for chloride. In the winter and spring, there are these massive spikes in chloride concentration from road salt runoff. And here I have some trends of chloride in the Great Lakes. So as with most things about the Great Lakes, Superior has the best water quality. And Ontario and Erie are kind of at the bottom of that list. So with as big as these lakes are, they are all still increasing for chloride. It's a little hard to see on these figures, but Superior also does have a slight upward trend for chloride. And they kind of seem to peak around the 60s or 70s and then drop off. That is when the Clean Water Act came around and we started regulating industrial discharge. So prior to that, a lot of that increase in chloride was from industrial brines that were directly discharged to the Great Lakes. We started regulating, that went down, but then we started using road salt and they have been steadily increasing again. And there really is no sign that they're going to stop increasing. So that just remains to be seen for the future. All right, I wanted to give an example of something to give hope, because I just, threw a bunch of bad information at you. This is something that we're seeing across the state of Wisconsin that has been a major help in reducing the amount of chloride that we use. So you may have seen some of these on the road. These are trucks that use liquid brine instead of rock salt to treat roads. So brine is just taking the regular rock salt and dissolving it in water before they apply it. So it's a huge tank that holds the brine and sprays the water directly onto the road before the storm happens. Using brine can reduce salt use by 40 to 50%, which is huge. So if we could get these across Wisconsin and across the US, that would make a really, really big difference in how our freshwaters are trending right now. And brine actually tends to work better than rock salt. It sticks to the roads and it doesn't just bounce away the way rock salt would. And of course, there's less salt, so it's less corrosive to vehicles and to infrastructure. And I think it makes things safer for our drivers too, because they're able to get out there before the storm even starts to pre-treat. So the roads are, safe as the snow is falling, rather than them scrambling to get out and to throw rock salt down. Okay. I want to talk about 3 things that are very simple that everybody can do to help reduce salt use. And the first one has to do with your driveway salting and your sidewalk salting. There are ways to do this that you use the appropriate amount of salt, so you maintain your safety, but you don't oversalt and add to our problem with freshwater becoming salty. So the best thing you can do is shovel as much snow away as you can before you start salting. And only salt where you need it. If there's an icy patch and you've got to get salt down, put it there. Maybe you don't need it over your entire driveway. And scattering the salt is really important. So each crystal can melt a good amount of water and keep that liquid. So you can have about 3 inches between each of your salt crystals. And a good rule of thumb is that 1 coffee mug full of rock salt is enough for a standard 20-foot driveway or for 10 sidewalk squares. Another thing about just regular rock salt, which is usually sodium chloride, it does not work below 15 degrees Fahrenheit. So that is something to keep in mind when the temperature drops and it's super cold. It's best to switch to something like sand so that you get that traction, because the salt won't do anything at that point. Another thing that we can do is learn about your water softener and how to optimize that. Not only will that help you save salt, but it'll help you reduce water use potentially. The Wisconsin Saltwise website has some really, really good resources about how you can do this, including a diagnostic where you kind of like step through and it asks you questions, easy questions. It has like pictures, and it will give you options and suggestions for how you can optimize your water softener. And the third thing that you can do is, share some of the things you've learned today and some of the things you know about how to appropriately apply salt with your friends and family and neighbors. Education is a really big part of changing the way that we use salt. It's a lot like, recycling. People didn't do it for a long time, and then it started being pushed on everybody through schools and through education. And by the government, and that is what really made that change. So we need to somehow get the word out so we can make a shift, a widespread shift toward a safer salt use for the environment. Okay, so I am going to stop with the talking there. My email is on this slide, so if you have questions that come up later that we don't address today, feel free to send me an email. I really like talking to people that way and answering their questions. I feel like it's my job as a scientist who knows a lot about this topic to make sure that you have the resources and knowledge to make the best choice for yourself. All right, so I will stop sharing my screen and we can move on to some questions.
Awesome. Yes, thank you so much, Linnea. Let me go ahead. All right, so if you would like to ask a question, please type that in the chat. The chat is denoted by the little conversation bubble icon. It's going to be either at the top or the bottom of your screen, depending on what type of device you're using. And you might have to move your mouse or tap the screen to make that the little chat button pop up. And oh, here we go. We have a question that came in. Am I correct that Port Washington is now using the liquid brine?
I actually don't know the answer to that question. I don't know if anybody on the call knows.
Yeah, I don't know the answer either, but that is a really good question that I'm going to look into after getting off this call for sure.
That is becoming, it's becoming a lot more widespread. So a few years ago, there was just like one county in Wisconsin using liquid brine, and they had such success with reducing their salt use and like proving that you can very easily maintain public safety and in fact potentially increase that safety by using liquid brine. So that has been growing throughout Wisconsin and has been doing wonders for salt use reduction.
Any other questions? Let's see.
Oh yeah, someone here says it's a mixture that includes beet juice. That's also a popular thing to mix with the beet juice to help it stick to the road. Beet juice can potentially have some trouble in fresh water if it's used too much. Like in this application, I don't think it's going to be a problem. But beet juice has a lot of sugars and it's an organic compound, so it is used for energy by critters in the water and can cause problems with oxygen demand. But I think in this application, it's a good alternative.
Great, and I have another question here. The question is using potassium chloride on my driveway just as harmful as sodium chloride?
Yes, so because it contains chloride, it does that same thing where the the chloride dissolves in the water and it does not leave. So anything that has chloride, sometimes these compounds work better at lower temperatures or are less corrosive. But if it has chloride, it is doing the same thing.
Okay.
There is one alternative that I read a little bit about called calcium magnesium acetate, and I'm pretty sure that's what's usually in that like blue salt or like blue de-icer or whatever it's marketed as. And that seems to be a good alternative for the environment and much less corrosive, but it's a lot more expensive than regular rock salt. So most people find they just can't afford it or would rather go with the cheaper alternative, which is why we really advocate for just appropriate road salt use. So scattering, shoveling, scattering, sweeping it up, once everything is melted, if there's still salt on your driveway, sweep it up and save it for the next time. because the good alternatives are exorbitant.
Okay, and we have another question here. Do you know anything about changes in agricultural practices that are decreasing salt in our groundwater and lakes?
That's a really good question, and I do not. Regulating things in agriculture tends to be a little tricky in Wisconsin. And I don't know of any practices that are changing there to help decrease the amount of salt that enters our water, unfortunately. I mean, that's another thing that's just gonna take more time and education and trying to get people on board.
Someone else says there's a product called Paw Safe that's supposed to be safe for dogs. Do you know what's in it?
I'm looking that up right now. I had not heard of that. And I'm not sure what is in it. Regular road salt is like, it does bother our dogs' little, soft pads. So if this is some sort of, it must be some alternative that uses a different compound. I'm not sure what's in it though.
Are there any links for printable fact sheets on salt use reduction that you recommend?
So I believe that Wisconsin Saltwise does have some printable fact sheets. I'll just put a link in here for their website. I think that they have some things you can print out to hand out to, whoever. And that is such a good website. I really recommend you go there. A lot of what I, said today is on that website, and more. Lots of great information.
Great. Another question here. Do you know where road salt is sourced and what the environmental implications might be for this sourcing?
Good question. So, salt is a naturally occurring thing in the environment. That's kind of one of the pros for using salt that people like to throw at you. It's natural. So it is sourced from natural salt mines. I think we actually get a lot of it from the state of Michigan, perhaps. But I know Wisconsin goes through this like bidding period before every winter where they get bids from various sources and we purchase based off the best bid. Good question about environmental implications for sourcing. So this is, it definitely does put chloride into our fresh water. And, sorry, I just got distracted by the chat. It does put chloride into our fresh water, as does mining. So there is like natural chloride in our waters. Like I said earlier, in Wisconsin, they should be around 0 to 10 milligrams per liter chloride concentration. And that's because as rocks break down, chloride is released. So it happens, but they should not be at those high levels that we are seeing and those spikes that we're seeing in the winter and spring months.
Okay, it looks like we have the link to the Safe Paw in the chat there.
Yes.
Anyone wants to check out that product?
Oh, yep. The zooplankton that eats algae is called Daphnia. And yeah, they're cute. They're my favorite zooplankton. And if you're out at the lake, sometime in the summer and you have a nice clear glass, you can scoop up some lake water and just let it settle for a second, and you can see zooplankton with just the naked eye. You don't need a microscope or anything to see zooplankton, and you'll just see these little specks zipping around. Of course, you won't see the resolution of like that photo that I showed you today, but you can see them zipping around, and that's one reason why we shouldn't drink lake and stream water directly without, any sort of filtration process, is because those critters live there, and there's also, bacteria and other microorganisms in there as well.
And Linnea, I'm interested to know, how did you become interested in limnology?
Yeah, good question. I feel like a lot of things. So I grew up in New Hampshire. I did not grow up on a lake, but I was always very, very close to water. There's a little pond like just down the street from me that, we were allowed to walk down to and play in. So I've always had this sort of connection. And as I grew up, I actually thought I wanted to be a veterinarian, which is what brought me to UW, because UW has a really great vet school. And I started taking some classes and sort of changed to a more ecological path. And I've just had some various work experiences, like some education where I did a lot of water quality education with kids in elementary and middle school. I was a volunteer scientist at one of our nonprofits in Madison, and I did a project on pharmaceuticals in water. And then I worked at the DNR in the Water Quality Bureau, and I just found that I really, really loved thinking about, how we change our environment and how that impacts freshwater. And it's kind of a feedback loop because, we need water, and if we change it and decrease the water quality, that is just going to make things worse for us. We have to figure out new ways to fix it, to fix the problem. So yeah, I'm just excited about water. There's a lot of things that built up in my life to get me to where I am today.
Awesome. Thank you for sharing that. All right. Are there any other questions? I am going to pull up the closing slide here. Oh. Last one. Okay. All right. Do you see any other questions in the chat, Linnea?
I do not. But again, yeah, my name is Linnea Rock. So my email is lrock@wisc.edu. And if anything comes up, feel free to shoot me an email, and I will try to get you the best possible answer.
Great. Okay. Oh. Whoops. Okay. So we will wrap up our conversation tonight then. If you're interested in learning more about Badger Talks, please visit the website listed on the slide, badgertalks.wisc.edu. I will be sending out a post-program survey via email to all attendees. So please take a look at that and fill that out if you'd like. It'll help us get a better idea on how to continue serving you here at the library. And thank you to everyone who tuned in. And of course, a big, big thank you to Linnea for sharing her work and her passion here with us tonight. All right, thank you everyone. Have a great night.